All right, for today, it's a math day, and so therefore shorter hour, and therefore since we graded homework, we don't have that much time, and I already taught you how to do reflections before, but I'll review it with you right now. Do you get that this is not a graph, but it's a decent sketch of x to the third? You know what I'm saying? All right, so that's a sketch of x to the third. Now, what if I wanted to do this kind of a reflection? Well, that's on the inside. Do you remember the high-vo thing? So what's on the inside? What does high stand for? Horizontal on inside. That is a horizontal reflection. Which way does horizontal go? I like to think of it as like horizon. It's like that. And it's a that-way reflection. I want you to just sketch. I'm okay with sketching for right now. What do you think? Go ahead and sketch it right on your homework there. What do you think that should look like when you reflect it? Left, right. Some people are, these are like, oh, that's easy. And other people are really get confused by them. So try to see which one you are. Okay, if we are reflecting it across the y-axis, here's the y-axis, then everything that's over here needs to go straight across to the other side and be over there. And everything that's over here needs to go straight across and be over there. So how many of you had something that would be like this blue line here? Oh, that was terrible, but I'm going to even try that again. Hold on. There. How many of you had something like the blue line? Okay, good. Then the reflections come easily for you. All right. If you're one of the people that doesn't come easily for, here's what you got to do. You make a bunch of points, and then you just put them straight across, go the equal distance, and put them over there. See what I mean? If you just move each point across the line, it'll work. What's the only point that didn't move? 0, 0, because it was the y-intercept. It already was touching there. If it was touching here, it can't go anywhere when you reflect it. Okay? All right. So that's a left-right reflection. How about if we put the negative in the front? If it's vertical on the outside, that's a vertical what? Reflection. And yes, I think a flip is a good description of it, but math-wise we call it a reflection. If it's a vertical reflection, you get that's going to go this way. All right. So to start with, how about we graph a parabola, and I'm just sketching right now. We'll go back and pick up the actual exact points in a second, but just trying to talk generalities here. Would you agree that generally a parabola looks like that? And this guy got moved, what does that mean? 5 to the right. Do you get generally that's what where my parabola is? Okay, now what's this outside negative here going to do? I really encourage you to think horizontal inside. That must be a vertical outside. That's a vertical flip. Do you get that it would generally look like that? Would I give you credit on the test for that answer? What is it missing? Exact points. To get exact points, you have two options. You can graph each point of the parent one perfectly, and then shift them all perfectly, and then flip them all perfectly, which in my opinion is really difficult. Or you can make an XY chart. I would make an XY chart and just pick some numbers and stick them in the equation. So, how do I do this? I pick wisely. I don't just grab any random number. I pick x's wisely. Can you see where this thing is? Can you see that generally speaking, I want x's that are in that neighborhood? Do you see what I'm saying? I don't want to just randomly pick an x. I want to pick an x that's kind of between 3, 4, 5, 6, 7 kind of zone. So that's what I do. 3, 4, 5, 6, 7 kind of zone. And then I will find my exact points. So I'm doing your homework with you, so I encourage you to do it with me. These are all assigned. If I stick in a 3, let's see what we get. 3 goes here. What's 3 minus 5? Negative 2. And then I square it. What's negative 2 squared? Negative 2 squared is 4. And then I throw on the negative at the end, and it is negative 4. Now let's go and see if 3 negative 4 was kind of close to where I said, yeah, I wasn't too far off. It's right there. That bright blue dot I just put up there. I was off a little bit though. See, I wouldn't have been right. But if I get a few exact points, that'll help me clean up my graph really well. There's 1 point. Now let's put in a 4. If I put in a 4 right here, I have negative 4 minus 5 squared. And then what's 4 minus 5? And then you square it. Positive 1. And then you apply the negative at the end. Negative 1. So 4, negative 1. And again, I wasn't that far off. I was pretty close on that one. Do you get the idea? How many points like that will you need on the test? 5. What if 5 don't fit? I'm reasonable. If they don't fit, then I'll accept 4. If you can get only 3 good points on the graph because they go off the graph, that's okay. I'm going to ask for 5, but if that's not possible, it'll be okay to give me 4 or 3. Or I don't think there's any that you'll always be able to get at least 3 points. So, okay, going back to this other one that I kind of just did a quick job on. I know generally it should look like this blue one, so I'm going to make the blue one again. But I'm going to be a little more careful and not make it so wide. And then I'm going to find exact points. X, Y. And then I'm not just going to pick randomly. My X's are kind of in this zone. Small positives and negatives. Like maybe negative 1 and 0 and positive 1. And maybe 2 and maybe even negative 2. Those would be some logical ones to pick. And then I see, okay, what happens if I stick in a negative 1 in here? That becomes positive 1, because it's negative of negative 1. This is important that you get that X is like a little parentheses, and the negative isn't part of it. The negative's in front of it. So when I drop in a negative into it, I'll have 2 negatives. So if I put in negative 1, here's how it reads. Negative of negative 1 cubed. And that makes positive 1 cubed. And that means 1 times 1 times 1. So it's 1. And if I look at my picture, negative 1, 1. Hey, that was right on. That's perfect. Now I'm going to put in 0. That's easier. What's negative 0? 0. What's 0 cubed? 0, 0, 0. Yep. I knew that one. Get the idea? Find 5 points. All right. So that's the 2 kinds of reflections that there can be. And don't forget to get points. That's the biggest deal. It's great to slide your little sketch over on your graph, but don't leave it as a sketch. It's great to have the sketch there in case your points start coming up over here. You'll be like, uh-oh, I'm doing something wrong. At least you'll know it's so far off, something's wrong. It's a great way to check yourself before you wreck your grade. All right, so this one, I think it's a little bit too long. So I'm going to tell you which ones you can skip. We're going to do the first few, and then we'll cut down a little bit at the end. Let me pause while I figure out which ones I want to take off. All right, I think 1, 2, 3, and 4 are really good ones. You may skip 5 and 6. Now 7 is completely different. I want you to do one like that. So do 7 and do 8. So far we just skipped 5 and 6. And I think we're going to do number 9 is really important. I have to do number 9. We're going to save number 10 for a future day, so you can skip number 10. It's a good question, but I think the assignment's long enough we can skip number 10. All right, so we skipped 5 and 6 and 10. Let me look at number 7 with you because I didn't really talk about that much. So let's see if you understand what to do here. F of x is this. They're saying we're starting with an absolute value. And isn't this telling you to move that absolute value somewhere? And then move it somewhere again? And then flip it? So why don't you write down what you think this function looks like after you do all this stuff? If you do this, it's no longer absolute value of x, it's absolute value of x plus 1. And then if you do this to it, I can subtract 5. And if I do this to it, I'll make it negative. They were just telling you what the question was in a weird way. So this one's saying, hey, start with a square root function and then do all of this to it. 1, 2, 3, 4 things to it. And then graph it. Okay? So 7 and 8 are going to be kind of the questions that will separate your A's from your B's. A lot of you guys will get B's in this class at the end. It's the people that are willing to fight through and figure out the weird, tougher ones that are going to get the A's. I'd be happy if you all do that. That'd be awesome. But it takes extra effort. Not everybody's willing to do that. So, okay, any last questions before I stop the video for today? Yes? How do you know if you're flipping it over the X or the Y axis? Good question. The question was, how do you know if you should flip it over the X or the Y? It really boils down to this. Where's the negative? Because there's an inside and an outside to every equation. If you're putting the negative on the inside, then it's a horizontal on the inside. You remember that thing? Horizontal on the inside, vertical on the outside. So if you see a negative in it, first of all, if this was a -5, that would not be a negative that's going to flip it. That means move to the right 5. You get that, right? It's the kind of negative where it's in front. Okay, so if I put the negative here, that's a VO. What do you think I mean by that? It's vertical on the outside. Maybe I think you were gone when I explained that, okay? So the stuff that's on the outside, those are vertical things. So that's a vertical flip. The stuff that's on the inside, it'll be horizontal if it's on the inside. So if my negative is right here, that means that you do a left-right, like a horizontal flip, okay? So if the negative's on the inside, it's a horizontal. If the negative's on the outside, it's a vertical. And then can you flip it both ways? Yup. First you flip it the one way, and then you flip it the other way if they put negatives in both. Yes? Good question. Always start on the inside. So it'd be the horizontal one first. All right, I think that was a great question. And that's all I have for the video for today.